So on to Wolverhampton Railway Station. This project was part of the phased construction of the new railway station, Wolverhampton, and it included a phase 1 demolition to enable phase 1 construction. Then the passengers would then be moved to the phase 1 building, thus enabling phase 2 to be demolished and reconstructed. The principal contractor on this job was Galliford Try, and the demolition contractor was Sam Evans and Sons. The client was Network Rail, and I was the CRED and lead temporary works engineer for the demolition contractor. I'm going to run through the 3 main parts of phase 2 demolition, which were completed earlier this year. The first task was the demolition of the parcel sheds. The process here was to progressively demolish the steel portal frames that were adjacent to the railway line, and there was also a disused line within the sheds too. So here you can see the area that will be demolished, the wall along the platform that was retained, and the proximity to the overhead gantry, which is also to be retained in the bottom right-hand corner there. This demolition works was split into 2. Outer possession works in green hatch and during possession works in solid blue. This was planned so that there was a minimum amount of disruption to the railway station and railway line, whilst the sheds could still be demolished safely within a reasonable amount of time. Here you can see a photo of the inside of those sheds with the castellated beams and columns making the portal frames. And then the wall on the left-hand side there is what would be retained, and the platform was directly adjacent to that on the other side. As the structure would be left standing while trains were passing, a key requirement was stability. We worked with Sammy Evans to plan the demolition works and produced a design that ensured that the structure remained stable during the demolition works. This included controlled deconstruction using large excavators with shears and grab attachments, and also leaving bracing in key locations, as well as providing some restraint ties to reduce the sway collapse mechanism on the railway, which you can see here. So we introduced a simple ratchet strap tension tie on each column, and this was easy to install, but more importantly, significantly reduced the risk to the railway. And this is risk reduction through design in practice here. Once the parcel sheds were demolished, which is shown in brown on the right-hand side there, the bottom right-hand side, we could then move on to the high-level demolition works, which were adjacent, and these are shown in purple in the middle. We carried out a stability assessment on this structure and planned the demolition works, produced the sequence drawings that demonstrated the structure would remain stable during the whole demolition process. And here we can see some images of the demolition works. The structure was made up of 2 levels over a basement. Each level was split into 2 slab spans by a central dividing wall. The slab spanned from left to right as you look at the photo, which is why we had to approach the demolition end on and work towards the railway, which is behind this building here. If we progress from the side, we would be removing one of the supports to the slabs as the demolition started, and thus resulting in a slab failure and risk of progressive collapse of the slabs that are underneath if they were overloaded. So we eliminated this risk by choosing the appropriate demolition methodology with the demolition contractor that would bring the structure down safely and in a reasonable amount of time as well. And then finally, the third section is onto the low-level demolition. So this covered the demolition of a single-story building and ground floor slab, which is the top left-hand corner of the that image on the right-hand side there. This was demolished with a smaller excavator because effectively the larger excavator couldn't operate on the elevated structure and couldn't reach, because the railway was on the right-hand side, and then on the left-hand side it was the phase 1 area, which had already been built. So that's why we had to use a smaller excavator. Upon site investigation and the works during the earlier phase 1, it was apparent that the raised ground floor slab had a very low capacity. Therefore, we designed a raised working platform for the excavator to operate on. This was formed of timber mats and steel beams, and then, so timber mats on most of it, and then steel beams and timber mats were used where on a particular span that was too large for the timber mats to span alone, and this worked very well. So as part of the demolition, we had to devise a method to carefully remove the slab, where some live services were located just below the slab soffit. This is another example of risk reduction through design. There was a crash deck beneath the slab, over the services. However, we worked with the demolition contractor to plan a cut and lift method in these areas, with traditional mechanical demolition with a breaker on the end of the excavator arm used where these services weren't. So this worked very well and ensured that the services were not damaged during the works. We worked very hard during this project to reduce risk, whilst also providing a buildable solution and workable demolition sequences. My efforts to reduce the risk and also communicate any residual risks were formally commended by the Network Rail project engineer, which is shown here. We worked very hard at Andon to highlight residual risks on our design documents and ensure that the site team have what they need to deliver a project safely. So now on to a sneak peek